To look at Antarctica from space is to see a continent of seamless white, a frozen dome rising thousands of meters into the sky, smooth, featureless, and seemingly dead. For most of the continent's recorded history, humanity knew Antarctica almost entirely through its exposed coastlines, mountains, and frozen surface, an immense frozen desert whose surface revealed almost nothing of the continent buried beneath it. How can an entire continent-sized landscape, mountains, valleys, lakes, and ancient river systems remain hidden on a planet we believe we have already mapped? The surface of Antarctica is only a mask. Beneath miles of compacted ice lies one of the most rugged, complex, and hidden landscapes on Earth. Driven by ice-penetrating radar, satellite gravity mapping, and decades of subglacial exploration, science has begun to reveal landscapes, some of which have not seen open sky for millions of years. What lies beneath the ice is not a flat bed of bedrock. It is a continent of extremes. Deep beneath East Antarctica lie the Gamburtsev Subglacial Mountains, a jagged range comparable in scale to the European Alps, with peaks rising thousands of meters, entirely buried under ice up to 4 kilometers thick. Beneath Denman Glacier lies a vast trough reaching roughly 3.5 kilometers below sea level, believed to contain the deepest known point on continental Earth. Beyond these mountains lie massive valley systems, including ancient preserved river landscapes formed before major continental glaciation. Some buried valley systems extend for hundreds of kilometers, comparable in scale to the world's Great Canyon networks. And trapped deep beneath that crushing weight are more than 400 identified subglacial lakes. The largest and most famous is Lake Vostok, a body of fresh water roughly the size of Lake Ontario. It remains liquid through geothermal heat, the insulating effect of kilometers of ice and pressure conditions beneath the ice sheet. Lake Vostok has remained buried beneath the ice and isolated from direct atmospheric contact for millions of years. These subglacial bodies may support isolated microbial ecosystems. Sampled subglacial environments elsewhere in Antarctica have demonstrated that life can persist in these dark, high-pressure environments. Their waters, sediments, and surrounding ice may preserve valuable evidence of how parts of the ice sheet moved and changed through time. These are not isolated, stagnant pools. Satellites have recorded subglacial lakes filling and draining into one another, proving that active water networks exist deep beneath the ice sheet. Under the immense pressure of the ice sheet, water does not simply follow the downward slope of the rock. It follows hydraulic pressure, allowing drainage pathways to cross rises in the buried landscape that would appear uphill on an ordinary map. Mapping this hidden continent is an ongoing scientific effort. Recent datasets such as BedMachine Antarctica version 4 and BedMap 3 have vastly refined our view of the bedrock. BedMap 3 alone added 52 million data points and 1.9 million line kilometers of measurements from decades of geophysical surveys. Yet large regions still depend on interpolation and modeling rather than direct radar lines. Even with advanced satellite and airborne sensors, vast stretches of the subglacial landscape remain unexplored. This buried topography is not merely a geographic curiosity. The hidden mountains, canyons, and water networks actively dictate how the overlying ice sheet flows, slides, and melts into the Southern Ocean, directly shaping global sea levels. Antarctica reminds us that even on a familiar planet, entire worlds can remain hidden in plain sight, locked behind miles of ice, waiting for the technology to look closer. The mystery does not end with discovering mountains and lakes buried under the ice. Because this hidden bedrock also preserves a record of a time when Antarctica was green, warm, and entirely unrecognizable. In part 2 of this special report, we will examine how the continent's lost coastlines and ancient climate shifts reveal a radically different past, and what it tells us about our future. And, as always, Stay curious.